Hello everyone. In this video, so let us see the important interview program so called TwoSum2, that is input arrays sorted. Okay. So this is from medium level. So first of all, let us see the problem statement. So afterwards, so I'll explain with the sample input. So for different approaches. Okay. So first here it's given that one indexed array of integers, so called numbers, okay, that is already sorted in non-decreasing order, okay. So generally we have zero indexed based array, right? Okay, but here one indexed array is given. That one you can notice in the first line, and next of all, so here values are sorted in non-decreasing order. So first I'll explain the difference between increasing order and non-decreasing order. So I'll take the two examples here. Okay. So all of you observe this. So first let us take example array values as 1 to 5, and next, so here I'm taking the duplicate values in the second example. Okay. So So for current position, if we take some variable called I, for the next positions, if we take the variable called j, so then you can notice one thing here. So in the first example, so that is each current position value is less than of the next position value. So you can check any positions here. Okay, so 1, 2, or else 1, 3, 1, 4, or 1, 5, so whatever it may be. So next of all, 2, 3, all this you can check here. So current position value is less than of the next position. Okay. So but if you take the second example here, okay. So same I and j variable values I'm taking here. Okay. So you can notice one thing here. So the I position values are less than or equals to of j. Okay. So here you can check. So the I position value is less than of j position. So but if you take these two positions, so this current position value is not less than of the j position value. At the same time, it's not decrementing here. Okay, it's not incrementing or decrementing. So that's why. So this one is we consider as non-decreasing order. Okay, this is an example for non-decreasing order, and this is an example for increasing order. So I hope so everyone understood this. Why it's required to understood this, let us see in the problem statement. Okay, next. So what is given here? So find two numbers such that they add up to a specific target number here. Okay. So on adding which array values, you'll get the same result of target number we should find here. That is a problem statement. Okay. I hope you understood. Next, let us see the next statement. Let these two numbers be called some numbers of index 1 and index 2. So here index 1 and index 2 values lies in between, so the 1 to the length. Okay. Uh, so I hope you understood what you need to the return here. Next, so the return statement is also given here in the next line. Observe. Return the indices of the two numbers called index 1 and index 2, so added up by 1. Okay. So here why it is given added up by 1 means, first suppose some 0 and first position values addition result if matches with the target. Okay. So here it's starting from the one indexed basis, right? Okay. So that's why we need to return result as 1 and 2 if 0 and first position values matches with target. Okay. That's why we need to add by 1. So as an integer array called index 1 and index 2 of length 2. I hope so you understood. So this next, that is information regarding the one indexed base. Because of its one indexed base, so for our result indexes, we need to add 1 here. Next, the tests are generated such that there is exactly one solution. So only one solution we have. And next here you can observe that you may not use the same element twice, okay? Because it's a non-decreasing order, right? Okay. So you can find the duplicate values. In that scenario, you need to not take same values, okay, which add up to the target number. So that is it. That's why it's clearly mentioned here. Because of non-decreasing order, chance for so we have duplicate values, right? And regarding so that information is given here. We should not use the same element wise. And your solution must use only constant extra space. That is, we should not take so that any extra arrays here. Okay, can use some extra variables. So if required. Next. Here some sample inputs and outputs are given. Let us take the first example. So here 0 and first positions values addition result matches with the target 9. So if 0 and first position matches, then we need to return first and second here. Okay. I give some examples. So sample input specifications given. Here in these constraints, so all of you focus on this. Okay. So here we have different length arrays. So starting from 2 to 3 power 10 power 4 range. So length arrays we have. This is important. This one we are going to discuss in detail in this so program. And so array values lies in between minus 10 power 3 to plus 10 power 3 here. Okay. So I'll take so the positive and negative values input combination so that you can understood. Okay. So for all types of inputs here. Next. And so already mentioned, so if you don't have so the knowledge which topic you have to prefer, so for designing particular solution, you can check so here. And after completion of so that you should so try to design so programs for similar questions. All these are required. So next to this, first I'll explain. So the brute force solution. Most probably, so for each and everyone, so the brute force solution so strikes, right? Okay. So let us discuss that brute force solution now. Let us take some sample and example. First of all, so called -4, -3, so +3, and so 5. So these are array values here, and let us take so target value called sub-zero. In some platforms, we need to check that on adding which two position values will get the result 0. Okay, that's why I taken the target 0 here so that you can work in different platforms also. In some platforms, we need to return the result as true and false also. Okay, so based on the platforms, okay, it changes here, but whatever it may be, you can so design all platforms. Next. So the brute force so solution so thought is one position value. So we need to add with all remaining position values and we should check whether so the result matches with the target or not. Okay. So means for comparing one position value with the remaining position values, we need to run the two loops. Okay. So first loop is so I as usual and so the next loop is j. So we need to start so j from the next position. So why it's required, I'll explain. So the later. So I'm taking so the j to the first position now. Okay. So here, so you can check -4 and -3. So this result is -7, which is not equivalent to 0. Okay. So the target value it's not matching. So I'm updating so the j here. So inner loop iterates. Next, so -4 and so the j position value is 3 now. So the result is -1. Once again, it's not matching with 0. Again, so j variable updates. Next, -4 and +5. So the result is 1. And once again, it's not equivalent to 0. J loop reached to the ending position. So next, so I variable updates to the next position. So j starts from the next of I. Here, you can so notice one thing. If we start so j from the 0 position, so each and every time, okay. So number of iterations so increases. It's not required here already. So these two positions we compared, okay. So that's why we are starting so the j from the next position. So I hope so you understood this one now. So the -3 plus 3, so the result is 0 and it's matching with the so the target. And in that scenario, we need to return so the indexes 1 and 2. Actually, 0 and first position values are matching. So to that, we should add +1 and we should return the result. Okay. So there is a brute force solution. Let us quickly see the execution part. Let us execute what we'll get. Let us see now. Okay. See here already. So method is given. Observe the method signature. So numbers array is given. Target given. We need to return the list of integers. So from the method here. First, so I'll take the length of array here. So because we need to generate values up to the n, right? Okay. So length of numbers with the help of length function, I'm taking the n variable value here. Next, first I am generating the values for I variable here for I n range of n. Next, what I said. So JLoop, we need to start from the next position of I, right? Okay, that is I plus 1 comma n. Next, and I and j position values we should check whether matching with the target or not, right? Okay, if matches, so what we should do here, we need to return the I and j position values added with plus 1. Okay, so this is the brute force solution. So let us run and submit this. Let us check. Yes, base test cases executed. Let us submit this. So observe how much time it's taking. Okay. See, we got time limit exceeded error here. Okay. So only out of 24, 20 test cases so passed here. So why those 4 test cases failed? So all this I'll explain in detail now. Okay. So before to that, so remember one thing. So to our program, so this time limit was scheduled. That is, our program at most should take the 1 second time. Okay, it should not cross 1 second time, and computer can execute 10 power 8 at utmost 10 power 8 instructions within a second. Okay, so now why it's required? I'll explain now in detail. First of all, we should calculate the time complexity here for this program. So listen now. Let us take the n variable value as 4, size of array as 4. So for I value 0, how many times j loop iterates? Okay, we should check how many times j loop iterates for each and every I value here. So that we'll calculate the time complexity. J loop iterates for 3 times. For I value 1, it iterates for 2, so on up to 1. Okay, means if you take some size as 10, so j loop starts iterates like this 9, 8, 7 up to 1. So this one you can write like this in mathematics, that is n minus 1, n minus 2, and so on up to 1. What is the n value here? 4. 4 minus 1, it's 3. So 3, 2, 1, like this you can write. So the formula for this one, that is NC2, is n into n minus 1 divided by 2. Okay. On deducting this, you'll get n square minus n divided by 2. The highest degree, so in this one is n square. So the time complexity finally of this one is order of n square. Okay. Now, so at most, so what is the n value? So we are taking here, let us check now. So that is 3 into 10 power 4. Okay. So let us take first of all just 10 power 4. So for just 10 power 4, so if you take this one, n square, okay. So 10 power 4 power 2, so what you'll get? 10 power 8, yes. So up to for 10 power 4 value, so there is no problem in it, because for 10 power 4, it's 10 power 8 instructions can execute within a second, okay. So but what about for this one? So 3 into 10 power 4. So for this one, definitely it exceeds the 10 power 8 here, okay. So those test cases are only failing here, okay. So means up to for 10 power 4 range length of array values, it's executing, fine. So no problem, but for 2 into 10 power 4, 3 into 10 power 4. For this, it's exceeding so the 1 second time, and we are getting so the TLE error here. Okay. Now, I hope you understood. Based on the constraints, so how we should prefer so the approaches here. Okay, we should not prefer the brute force. We should move on to the another approach, the optimal solution. So next to this, okay, so that is nothing but so the two-pointer approach, which is the variant of binary search, and the same thing you can observe in the topics here. Okay, so this two-pointer approach, so we can apply when the data is in sorted form. Okay, we have so another program for two sum in which array is not sorted. In that scenario, we should not prefer the so two-pointer approach. Okay, so first I'll explain so the two-pointer approach here. Okay, later on let us see the implementation part. Okay, let us take the same example. So that is target is 0 and so array values minus 4 minus 3 plus 3 5 and now so in two-pointer approach so might be if you have knowledge on binary search you know this. Okay, for beginning positions it'll take start pointer, and for the last position so it'll take the end pointer. Afterwards there we go for calculating mid, but here it's a different variant of binary search. So just we go for adding starting and ending position values and check whether that result matching with target or not. Okay, so that we can reduce the so iterations here. Okay, so to order of n square time complexity. So at most we can reduce to the order of n here, not to order of n log n. Only one time, so the just loop iterates here. N time, so loop iterates. So it is going to be reduced. The drastic. Next. So let us check now. So minus 4, it's minus 3, minus 7, not is equals to 0 here. Sorry, it's my plus 5, right? Start position value is minus 4 and end position value is plus 5. And so the result is plus 1. It's not equivalent to 0. And we need to check one thing here. So this result, some result is greater than of target value, so that is 0. So if for suppose sum is greater than of 0, on updating, so the start pointer to the next location. So what we are going to get? So let us check. So minus 3 plus 5. So what I'll get? Plus 2, right? See, the result is it's incrementing, so not decrementing, but we want, so the target value is 0 here, okay? So on updating, so the start pointer, it's going to be incremented, but not so decrement. So that's why in this scenario, what you need to do? So end pointer, we should decrement to the previous location. So that is to this one. So if we get some result, it's greater than of target, then we should decrement the end pointer by 1. Okay. Again, so let us add the start and ending position values minus 4 plus 3. It's minus 1 now. Once again, not equivalent to 0. Now, minus 1, it's less than of 0. Okay. Now, on updating, so the end pointer to the previous location, what will get? Minus 4 and minus 3 will get minus 7. See, again, so the result is reducing, but it's not incrementing here. So in this scenario, we should update start pointer to the next location here. Okay. If we found, so the result is less when compared to the target, we should go for incrementing start. Okay. So by 1. Next, so finally now, so start and ending position values are minus 3 and plus 3. So which is 0 and equivalent to the target. Okay. So now we need to return the so position values here, so called 1 and 2. Okay. I hope so clearly everyone understood. So this here until start is less than of end, we should keep on repeat the loop. Okay. So for updating so variables based on so the different constraints, okay, we use while loop. You all know this. With the help of while loop, I'll frame the condition. Okay, let us see the implementation part of this one, and let us see whether we'll get TL error or not, how much runtime it takes, all this. Okay, so observe now. So let us reset this code and observe. Okay. So start and end pointers I'm taking to the 0 and so the last position here, and so the condition is start less than of end. Okay, until start reaches to end or crosses end, it keeps on repeats the loop. Okay, And first I'm collecting the sum result here of starting and ending position values, numbers of start plus the numbers of end. Next, let us check whether this sum is matching with the target or not. Okay, if matches, there itself you can stop and return. So start plus one and end plus one position values. If not matches, then we should check whether sum is crossing the target or not. If it is crossing the target, we should decrement end pointer by one, right? In the example you observed. Next, if it is less than, so then start pointer we should increment so by one. This is the solution, simple one. So now it's order of n time complexity, nested loops not involved here, two loops with the single loop we completed it. Okay, we are not using any extra space, best space complexity and time complexity program here. And let us test and submit as base case is executed. Next, let us submit. Observe as all test case passed and it just taken 3 milliseconds. Okay, so it beats 81.13% of solutions. Okay, so in this way, based on so the constraints, which approaches you have to prefer, all this you need to understood. Okay, so from this program, so that's it. I hope so each and everyone understood so this program. Okay, so thank you everyone.